Hi everybody, this is video lecture number 2 for chapter 14, Mixtures and Solutions. Relatively straightforward today, and this should only take a couple of minutes. The first thing we want to look at is that here we have a solute. The solute is an ionic crystal, so it has negative and positive charged ions. If the negative and positive charged ions are a very strong force of attraction, the solute will not dissolve in the solvent, in this case, water molecules or water. So if the attractive forces between solute particles and the solvent particles are greater than the attractive forces between the solute particles, the solute will dissolve. So this is described in this next section, aqueous solutions of ionic compounds. We call it a molecule-ion attraction. The molecule is water, a polar solvent. The ion is the ionic solid, like we saw above. If water is the solvent, this is called hydration. The polar water molecules will pull the charged ions away from the solid. We say the crystal lattice of the ionic solid is destroyed. If the aqueous solution is molecular, meaning that the compound is composed of all nonmetals, and if it's polar, then it's going to have something similar, or in this case, a an attraction of an ion of a hydrogen bond caused because the sucrose molecule has an OH bond in it. So since like dissolves like, the hydrogen bonding in the water and the hydrogen bonding in the sugar crystal will cause the sucrose molecule to break apart. If you don't have hydrogen bonds, then there is no dissolving. So C2H4 will not dissolve in water because it doesn't have hydrogen bonds and it is a nonpolar substance. So that page of the notes describes dissolving. Now, the last thing we're going to talk about are factors that affect the rate of dissolving. The first rate, so just imagine if you have made Kool-Aid or coffee, what are the ways you can get the solute to dissolve faster? One is by stirring. When you stir, you bring fresh solvent, like water, in contact with the surface of more solute particles. Temperature is number two. If you increase the temperature, you increase the kinetic energy of the water molecules, which increases the force of the collisions between water molecules and the surface of the solute, which allows more of the solute to be bumped off. The third factor is particle size. A fine powder dissolves more rapidly than large crystals because fine powders have a greater surface area. And the greater the surface area, the faster the rate of dissolving because more of the solvent is in contact with the solute. So that's it for this lesson, and have a great night.